This is the ammonia ion, NH4 plus. Sorry, ammonium. If it ends in it's an ion, and if it's ammonia, it's NH3. So this is ammonium ion. And what we can do is draw a Lewis structure, and to do so we first have to figure out what the valence electrons are for each of the substituents, and we'll start a count. So we're going to figure out how many valence electrons the elements want, and we're going to figure out how many they have. So let's go take a look at the periodic table. So we're looking for nitrogen and hydrogen. So hydrogen has one valence electron. It's in this first column, so it has one valence electron. And nitrogen is in 1, 2, 3, 4, 5, so it's in this 15 column, so it has 5 valence electrons. So since I have 4 hydrogens, that's 4 times 1 each, plus nitrogen, that's 5. And then this plus charge means that we have 1 less electron than we would get by having all of these elements come together as neutral elements in the periodic table. So I'm going to subtract 1 valence electron. So this is a good way to catch students in exams. If you have a plus charge, that means you're going to be subtracting an electron. It's like there's an electron missing. And if you have a minus charge, you're going to be adding an electron. If you have a minus 2 charge, you're going to be adding 2 electrons. If I had a 2 plus charge, I would be removing 2 electrons. That's why it's minus, because the plus charge indicates I'm missing a minus charge or I'm missing an electron. Okay, going back to the periodic table, looking at hydrogen. Hydrogen is in this first row. That means that it wants to fill a valence shell of electrons that only has 1 orbital and 2 electrons. So it wants to have the configuration, the electronic configuration of helium. So that's 2 electrons that it wants. Nitrogen wants to have the electronic configuration of the next noble gas, neon. So it wants to have 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And it only has 5, but it wants 8. So going back to our calculation, there are 4 hydrogens and they each want 2. And there's 1 nitrogen and it wants 8. So overall, through sharing, these all want to be surrounded by a total of 8 plus 8 is 16 valence electrons, but they only have 4 times 1, that's 9, minus 1 is 8. So in this Lewis structure, we're going to have bonding electrons that are the difference between these two numbers. They're the number of double counted or shared electrons that are going to be involved in covalent bonding. So 16 minus 8, that leaves us with 8 bonding electrons. Now notice that since we have 8 valence electrons and we have 8 bonding electrons, that means there's going to be no non-bonding electrons, because they're all being used up in bonding. So 0 non-bonding electrons. So let's go ahead and start drawing out the Lewis structures of these things based on their valence electrons. So hydrogen is going to be a terminal element. You can't really have more than 1 bond to hydrogen. So I'm going to put hydrogens around the nitrogen, and I'm going to assume that nitrogen is a central atom here. Not a bad assumption since there's 4 hydrogens and just 1 nitrogen. Maybe the nitrogen's being more the focus. Not a bad idea. Then I'm going to add a valence electron next to each hydrogen, and I'm going to add 5 initially around nitrogen. But then I am actually going to remove a valence electron because there's a plus charge. So I basically turn this nitrogen into nitrogen plus. So just to make sure I'm not crazy here, let's count up the valence electrons to make sure I haven't done anything weird. I count 1, 2, 3, 4, 5, 6, 7, 8 total so far, which is right, that's what we start with. And I'm just going to turn these all into bonds. So each hydrogen can have up to 1 bond. So I'm just going to replace a pair of electrons with a bond between nitrogen and hydrogen over and over and over. And there's a little bit of weirdness here because there's 2 electrons there. So I'm just going to erase those 4 total valence electrons and replace them with 2 bonds. Okay. So overall, this thing, according to its formula, has a charge. So I'm just going to draw like a little bracket to indicate that overall this thing has a charge. Put a plus charge outside the bracket. And let's see what else I can do. Doo-doo. Okay, so I'm just moving, whoops, this stuff to make it a little bit nicer looking. So we have 1, 2, 3, 4 bonds. That's 8 bonding electrons, which is what we said we'd have. There's also only 8 valence electrons depicted. So this is the right formula. Nitrogen has 8 electrons surrounding it. That means it has a complete octet. Each hydrogen has 2 electrons surrounding it, so it has a complete duet. So this is how you would draw the Lewis structure for ammonia. If you wanted to figure out what the geometry of ammonia is, you would determine how many things are surrounding ammonia. So, sorry, I keep saying ammonia, it's ammonium. So you figure out how many things are surrounding this central nitrogen. There are 4 bonded elements to the central nitrogen. There's no lone pairs, so it's just 4 things. So that will mean that it has a parent structure of tetrahedral, a parent geometry of tetrahedral. And since it has 4 elements bonded to it, it's just going to be tetrahedral. So this thing is going to be a kind of like a pyramid. The dashed lines mean that I'm trying to draw something receding from the board or the plane, the Microsoft Paint board that I'm using. And the dashes, so the wedge means it's coming out of the plane. The dashes mean that it's going into the plane, away from you. And these straight lines mean that it's in the same plane as the Microsoft Paint. So that's what the geometry looks like. These should all have like 109 degrees, 109.4 I think degrees, and this is tetrahedral. So that's the geometry of it. This is the structure, like the Lewis structure, and that's how you do the problem.